All right, guys, this is the Unit 4 test review, exponential and logarithmic functions. We've got a test next class. I'm going to go through this. As always, pause it if we are moving too swiftly for you to copy down. But number one, the key thing here is same thing for the test. You need to graph at least 5 points for this function. And you obviously cannot see this, but I am just going to insert that in my calculator, my y equals, and look at the table and pick 5 points from the table and graph those 5 points. Obviously, for this graph, it's tough to get 5, nice, neat whole number points. So we're going to have to graph some decimals. So here's the 5 points that I picked. You could have picked 5 different points, but ultimately your graph should look pretty similar to what I've got right there. The negative value in front of the 3, that's the reason that graph kind of has a downward trend in this problem. That's essentially what your graph should look like. And then the domain and range, it's been a while since we've talked about those two things, but the domain for this, remember the domain is the x values, which means how far is that graph going from left to right. And that graph is going to the left and is also going to the right forever and ever. So all the x values are being covered in this graph. So the domain is all real numbers. The range is how far up and down the graph is going. And you'll notice it is going south forever, essentially. So that means the graph starts at negative infinity because that's the smallest y value. And it goes up to a point. It never quite actually touches that value right at -1. So our range is everything from negative infinity to -1. And then I believe that's the only actual graphing question on the test. So we move more into logarithm form. And you'll notice for questions 2 through 5, and really any questions after that, you've got all your formulas right here. Look very similar on the test. You'll put your formulas for the logarithms in one place. So we've got all the log properties, and you've got log form, and you've got exponential form. So as we read the instructions for questions 2 through 5, it's asking, write the given equation in log form or exponential form. So question 2, it obviously has a log in the problem. Since it has a log in the problem, that means it's in log form. So it's in this form, log base y x. At this point, I think most of you have that formula memorized. Don't even need it on the test. And we're converting it to the other form. We're converting it to exponential form. And the shortcut is we just take the 3, we raise it to the 4th power, and it equals 81. Converting from log to exponential, I think, is a little bit easier because this answer you can verify really quickly in the calculator. If you type in 3 raised to the 4th power in the calculator, you should get 81. So this one actually you can look at and tell that you have the right answer. The next one, we're going the opposite direction. There's no logarithm on number 3. So that means it's in exponential form. So we want to convert it from exponential form to log form. It's just a matter of identifying what the b value is. The b value is 5. So that means the 5 is going to go in right here in log form. The x value is -2. So that means -2 is going to go in for x. And then finally, this last value right here is y. So that's going to go in the spot for y. All right, so that's what your answer should look like in log form. And again, you could verify it by converting it back. This number, the base, raised to the negative second power. 5 raised to the negative second power does give you this fraction. So be sure on the test, check and recheck your answers. Same thing on 4. I'm going to start going through these quickly. I encourage you to try these on your own before I go through them. But number 4, it's in log form because there's a log in the problem. So exponential form would be b raised to the third power equals 8. Or you could say 8 equals b to the third power. Either one of those would be acceptable. And then the last one is in exponential form, so we just need to convert the last one to log form. So the base is 4. I'm going to put a 2 over here, put my 16 right there, kind of overlapping the line there, but that should be your answer in log form. And I just realized now that this was a multiple choice question, so that should make it a little bit even easier for you. The choice for this one was B. All right, 6 through 8, it wants us to expand the expression. So we start with one logarithm, so we want to expand this to multiple logarithms. Remember the hint I think I gave you a few days ago? There are 2 things in this problem. There's a 5 and there's a 2. So that means when we expand this problem, it should expand to 2 different logarithms. So 5 divided by 2, look up at your properties. Division, of course, converts to subtraction. So this is log base B5 minus log base B2. And that is your answer. Why I did not put that on the answer line, I don't know, but it goes there on the answer line. Notice the base does not change for number 6 at all. Number 7, same thing. You've got 3 things in this problem. You've got a 12, you've got an x, you've got a y. So you've got 3 things, so that means our answer is going to have 3 logarithms in it. You're multiplying the 12, the x, and the y, and multiplication, of course, converts to addition. So that should be your answer to number 7. Be careful, a couple of you on the quiz, sometimes the base, it's not really clear what the base is in the problem, so make sure you clearly write so I can see that 8 is the base and 12, x and y are not actually the base in this problem. Then finally, number 8. Number 8 has 3 things. It has an x, it has a 3, and it has a y. So our final answer should contain 3 separate logarithms. I always like to get rid of the fraction first. So I'm going to do this in a 2-step process. So log x minus, since division converts to subtraction, log 3y. This would not be full credit if you left it right there. That'd just be half credit because we can expand log 3y into 2 separate logarithms itself because you're multiplying the 3 and the y. So that 3 times y will convert to addition. So that becomes log 3 plus log y. And I do want to put that in parentheses since I am subtracting all of that. I'm subtracting the log 3 and the log y, and that's what that subtraction, or that's what the parentheses tell me in that problem. So here's my answer for number 8. So for 9 through 11, we're going the opposite direction. We're condensing the expression. We start with 3 logarithms on number 9. We want to condense it to a single expression. So we read number 9 from left to right. And I'm first going to combine these 2 logarithms. Subtraction, of course, converts to division. So this is log base B 2/3, or 2 divided by 3. And then what I've got left over, I've got plus a log base B12. Of course, addition converts to multiplication. So our answer here is log base B, and then here off to the side, I'm going to multiply 12 times 2/3, which we of course can do in the calculator. 12 times 2/3 should be 8. So that's our answer for number 9. Number 10, we're going to use the third log property rule here. The 5 in the front. An equivalent way to write that would be, instead of 5 log x, we can write it as log x to the 5th minus log y, since there's nothing in front of the log y. Well, again, we want to condense this to a single expression, so that subtraction sign right there. Subtraction, of course, converts to division. So our answer is log base 10, which we don't have to write. X to the 5th over y, or x to the 5th divided by y. 11 is similar. You're going to start that one the same way. 2 log x becomes log x squared. 3 log y becomes log y to the 3rd. We've got all different variables in this particular problem, so we won't completely be able to combine all of these. And then minus log z to the 4th. So that's our first step. Our second step is we're now going to combine these two logarithms right here, because we're going to read it from left to right. And addition converts to multiplication. So I'm going to write it over here. Log x squared plus log y to the 3rd now becomes log x squared times y to the 3rd. And then don't forget all of this right here, minus log z to the 4th. But again, we want to condense this to a single logarithm. We've condensed it to 2 logarithms. So to condense it to a single logarithm, that subtraction, we know, of course, converts to division. So we're just going to divide x squared y to the 3rd by z to the 4th. It's just the process of knowing those log properties and applying them in the right situation. So that's our answer for number 11. So that would go in the number 11 blank right over there. 12 and 13, you're going to use this formula. And again, this will be provided for you. You need to know what each of those variables represent, though, for the test. So we deposit $7,200 in an account with a 12.5% interest rate for 21 years. So this is going to be my P, because that's my initial principal, my initial investment. This will be my R once I divide it by 100. So I'm going to divide 12.5% by 100 to get my R. And then the 21 is going to be my time, because that's our time in years, how long we've invested the $7,200. The N variable comes from how many times this is compounded. So number 12, it says that it's been compounded annually. So that means it's been compounded just once. So that means N equals 1 on number 12. Number 13 says it's compounded monthly. So that means N equals 12, since there's 12 months in a year. So now this is as simple as substituting all those values into the formula. So there should be the setup for number 12. Again, don't be a hero, guys. Take this formula one step at a time and you'll get it correct. First thing I would put in the calculator is 0.125 divided by 1, which in this case that's pretty easy, because anything divided by 1 is just itself. So I'm going to figure out what goes in the parentheses here, and that's just 1.125. Separately, I'm going to multiply these two numbers. Again, this one's easy because it's just 1 times 21. The next one won't be as easy. And you got to remember your order of operations. Please excuse my dear Aunt Sally. PEMDAS. So you need to raise 1.125 to the 21st power first, and then multiply by 7,200. So my work is bleeding over a little bit here to the next problem, but this is going to be 7,200, and then times that decimal. Really, you can, once you get that decimal, 11.86323057, I would just take that decimal and then multiply it by 7,200 immediately. And the final amount after 21 years is a pretty good amount. It's 85,000. I'm going to write it right over here in the blank. It's $85,415. Since we're talking about dollars and cents, we want to round that off to the nearest cent. So that's our value for number 12. We're going to repeat the process for number 13. The only difference is we are going to have a value for 12 for n. And this should be the setup for number 13. So I did a couple things here. I did 0.125 and I divided by 12. And after that, then I added 1. That's where the 1.01 is coming from. Of course, 12 times 21 is where I'm getting the 252. And last but not least, order of operations, exponent before multiplication. So if you did the exponent before the multiplication, you should have gotten $88,372. And all right, if the nearest cent, that would be 82 cents. So that answer goes right there to number 13. You can pause it if you need more time to copy that down to work. All right, so 14 through 22, we just did a lot of problems like this in the last few days. We're just solving each equation. So number 14 is in log form. So that means put it in exponential form to solve it. So that means 7 raised to the x power equals 2401. So you can do two things here to solve for x. One, if it is a nice, neat whole number, you could guess and check. I'm going to go ahead and just be consistent. I'm going to work out all of these exactly the same way. So I'm going to take the log of both sides, and I'm going to use the third exponent rule, which moves that exponent x to the front of the logarithm. To solve for x, just divide both sides by log 7. If you're a person that likes to do every problem the same way and can only really remember one way to work out every single problem, this is the way to learn, because you cannot guess and check on most of these problems. So type in log 2401 divided by log 7. Should get 4. Log 2401 divided by log 7 should be 4. 15, same thing. It's in log form. So again, to solve it, I'm first going to convert it to exponential form. The base is not given, so I know it is 10. I'm going to raise it to the 0 power and set it equal to negative 4x plus 2. If you don't know what 10 to the 0 power is, do not guess. Always check in the calculator. Of course, anything to the 0 power is 1. Then from there, it's just a two-step equation. Subtract 2 from both sides and then divide by negative 4. So your answer to 15 is 1/4, 1/4, 4.25. Moving to 16, it's in log form, so we do want to convert it to exponential form. But before we do that, get the logarithm by itself, or get it in complete standard logarithm form by dividing both sides by 5. So we end up with that on number 16 once we divide both sides by 5, then put it in exponential form and solve it. So 16 should equal 4/3, or you could say 1.3 repeating. Either one of those would be fine. 4/3 probably the better answer since it's a never-ending decimal, but 1.33 or 1.3 repeating, that'd work too. Either or. All right, 17. That's not one you can guess and check on. You do have to show your work on problem like 17. It's in exponential form, so we want to use logarithms in this problem. We want to get that x minus 3 out of the exponent spot. And the only way to do that is the third log property. So I'm going to take the log of both sides. And once I take the log of both sides, third log property, we can use that to move the exponent x minus 3 to the front of log 2. All right, so that's what this problem looks like after we do that. We want to get x minus 3 by itself. So we're going to undo that multiplication by dividing both sides by log 2. Anything divided by itself just cancels or gives us 1. Log 40 divided by log 2. We can just input this into our graphing calculators to get an approximate value for that. So log 40 divided by log 2 is 5.32, rounded to the nearest hundredth. Again, as long as you've got all the work like I've got right here, you've got a lot of work, you're showing that. I'm not going to be too particular about how you round. So if you rounded that to 5.3, that's fine. And then the last step here, of course, just add 3 to both sides. So x equals 8.32. So that's the answer to 17. All right, 18. 18 is an exponential function form. You cannot guess and check on this. So again, if it's an exponential form, put it in the other form. Use logs to solve this problem. So I'm going to take the log of both sides. I'm going to do the third exponent rule. And then to solve for x, I'm going to divide both sides by log 3. So x is going to equal whatever log 33 divided by log 3 is. So just insert that into your calculator to get that approximate value. So 3.18 is what I came up with. If you put 3.2, as long as you showed your work. Again, if you don't show work on problems like this, you cannot get any credit because you do need to solve it this way and not by guessing and checking, since it's kind of a crazy decimals and answer there. All right, last couple of these solving problems. Number 19. So 19's got the dreaded natural logarithms that I think have given some of you guys fits this chapter. So since there are logarithms in the problem, that means we are going to convert this to exponential function form. But before we can do that, we need to combine those two natural logs. Subtraction converts to division. So this is the natural log of x divided by 3 equals 2. It's not given in the problem, so that means the base is e for the natural log problems. So now that we've got it converted to one logarithm, now convert it to exponential function form. An exponential function form would just be e to the second power equals x divided by 3. Type in e to the second power in your calculator. So e to the second power, round to the nearest 100th, is 7.3. be 7.39. And then to solve for x, since we're dividing x by 3, to undo that division, we're going to do the opposite. We're going to multiply both sides by 3. That crosses those out. That's going to leave us with x equals so 22.17 is the answer to number 19, because 3 times 7.39 is approximately 22.17. All right, number 20, there will be a question very similar to number 20. Different numbers, but same process. 20, a lot like 19, we are going to put it in exponential form. But before we do that, we need to convert the addition of those two logarithms to multiplication. So that becomes log base 3 x plus 4 times x minus 4. That's one you should be able to multiply together. Either box method, FOIL method, whatever method works for you. Multiply x plus 4 times x minus 4. So x plus 4 times x minus 4 should just yield us x squared minus 16, because negative 4x plus 4x cancels out. So we've got log base 3 x squared minus 16 equals 2. So now that we've converted it to one logarithm, now put it in exponential function form and solve this for x. So it's 3 raised to the second power, which of course is just 9, equals x squared minus 16. So real quickly, there's the work. X squared equals 25. That means x would just equal positive 5, because your last step here would be to square root both sides. So that's our answer for number 25. 21, we looked at a problem like this yesterday, or at least there was one on your quiz like this. You should have added 3 to both sides first on this problem. So that leaves us with e to the x power equals 82. So it's in exponential function form because e is a number. So that means we want to put it in logarithm form. So the only difference between this problem and other problems we've done like this is instead of taking the log of both sides, we're just going to take the natural log of both sides. And then everything else in this problem is identical to how we solved these earlier. Third logarithm rule, looks like that. To solve for x, divide both sides by the natural log of e. .41 is your answer for 21. And pause if you need to copy down the work. And then last but not least, at least relative to the other problems, this one I think is fairly easy. It's in log form, so convert it to exponential form. Base is 10 raised to the first power equals x minus 1. So that means x is just going to equal 11 after we add 1 to both sides. All right, so we finished with some application problems for this unit. For these last few problems, 23, we have 57 deer in a small forest north of the Columbia River. The deer are repopulating at a rate of 3.5% per month. So that means if they're repopulating, that means they're growing. Their population is getting bigger. So part A says at this rate determine an equation that models this situation. And we're going to use an equation in this form, where A, remember, is the initial value of the population of deer, which is just 57. B is either the growth or decay factor. In this problem, since it is a growth problem, B equals 1 plus R. So since it is a growth problem, B equals 1 plus R. So that means B equals 1 plus 3.5 divided by 100. It actually might be easier to divide 3.5 by 100 first and then add 1 to it. So it means B equals 1 plus 0.035. So that means an equation that models this situation is Y equals 57 times 1.035 raised to the x power. We don't need parentheses here really in this equation anywhere. That's it. That's your answer. And then the question says, at this rate, how many deer will there be in the forest after 1 year? So this question is a little tricky here in this particular problem, because in the problem it tells us that deer are repopulating at a rate of 3.5% per month. So this rate they gave us was per month, and the question is asking how much there will there be in 1 year. So that 1 year we just need to convert to months. Of course, 1 year is just 12 months. To figure out how many deer are in this forest after 1 year, we're just going to replace X with 12. The deer repopulating kind of slow, so when we do the math, you should end up getting about 86 deer. Remember, we don't want decimals since we're talking about deer. So that's your answer for part B. We're not going to do C, so you can mark out part C for number 23. So 24, we're going to use the same equation model that we used on 23. The only difference in this particular problem is it is a decay problem. So that means in this particular problem, B equals 1 minus the rate. For this problem, that means B equals 1 minus 0.135. So the equation, write an equation that models this situation. We don't want to insert anything for Y or for X. We just want to model for this problem. So 53 is the initial amount of caffeine that's in Minkus's system. So Y equals 53 times 0.865 raised to the x power, because 1 minus 0.135 is 0.865. So now we can use that equation to answer part B. It wants to know after 6 hours how much caffeine does Charlie still have in his body. The problem tells us the decay rate up here is per hour. So that works here for this problem. So that means we just insert 6 for X. And I got roughly 22.2 milligrams of caffeine. And since it's decaying, it makes sense that it is a smaller value. So that is the answer to part B. So for part C, you're going to insert 24 for your time value now, because 1 day, of course, is 24 hours. And then you insert that, and he's almost got no caffeine in his system after 24 hours, assuming he hasn't had any more coffee. I've got about 1.63 milligrams. All right, so finally 25 and 26. Earthquake problem, we talked about this just last class. We're going to use this formula here. R is the Richter scale reading, I is the intensity or energy of the earthquake. They give us the Richter scale reading. They give us the Richter scale reading of 5.2. So it's in log form. To solve for I, you're going to put it in exponential form. So it's just the base is 10 raised to the 5.2 power. Whatever that comes out to be, that's your intensity for this problem. So that's the answer to 25. 26, we're going the opposite direction. It tells us in this problem it produced this amount of energy. It wants us to find the Richter scale reading. So in this particular problem, we're solving for R, and they give us I. So this is just as simple as inserting that huge giant number in for I and just typing that in the calculator, log of 2,130,998. We may have done this problem yesterday, the 6.33 or probably just 6.3 would be fine there too. So for 27, we're going to use the pH formula. They give us the pH of 3.3. It wants us to find the hydrogen ions. So that means H plus just equals 10 to the negative 3.3 power. And that's for Red Bull. And then you're going to do a very similar thing for this person's urine. H plus equals 10 to the negative 5 power.